based out of New York. I'm very proud of it. In many sense, we are pretty OG in crypto. The company was officially registered in 2015. So predates Ethereum, predates the Ethereum white paper, and we're basically a bunch of computer scientists. My background is on distributed systems. I did my PhD at Princeton. Same with. Is this better? Yeah. Okay. Same with Jude as well. He also did his PhD at Princeton, and think of us as kind of like distributed systems engineers who are really interested in upgrading the internet, like upgrading the core internet infrastructure. And we discovered blockchain, and then it was a rabbit hole, right? Like as you all know, it's a fascinating technology with many different parts to it, and we've been just going down deeper and deeper in this rabbit hole. So what is Blockstack? Blockstack is a user-owned internet, so think of that as a software stack. And the core foundational layer is kind of like a blockchain, but there's a lot more to it. There's a storage piece, there's authentication. We will touch that a little bit, but we want to focus more on the smart contract language and the new consensus algorithm today. Before I start, here's a standard disclaimer from our legal team. Being an engineer, it's always feels weird to start presentations this way. But we actually last year, some of you might be familiar, we actually did the first ever SEC qualified offering of crypto assets in the US. Right? So we did that a unique route where, instead of doing something and hoping that, hey, it may or may not be legal, we actually sat down with regulators and figured out a compliant path for doing such offerings. Which also means that, we're a small, kind of like 30% team, but we currently need to operate like a public company. Public disclosures and disclaimers. So this disclaimer pretty much says that I'm not selling anything. Please don't buy any crypto asset after seeing this presentation, and there might be certain forward-looking statements in this presentation. So just a quick overview of Blockstack. Think of this as we were in R&D phase, and which is again a little bit of a unique path, right? Like in crypto, people kind of like just like throw up their paper designs and run with it, and that's great. It leads to a bunch of innovation pretty quickly. Us being the computer scientists, a bit careful, we want to test out everything, we want to get peer reviews, we want to be careful around how we navigate this. This project stayed in R&D phase for a fairly long time. We raised venture capital, and then we started rolling out our infrastructure and our designs, and then 2019 is really the year where developers could actually build meaningful things on top. And we saw apps. So think of this as these are more general purpose Web3 applications, like a decentralized blogging software or decentralized photo sharing, without any really smart contract functionality, because smart contracts are going live now with the Stacks 2.0 launch. And we saw amazing growth, like apps went from something like 27 to now more than 400 on top of the platform, and we've learned a lot, and we're trying to iterate and like build better developer tools for you guys. So think of Blockstack as actually. Let me give you a little bit of a high-level pieces overview first. Right? I think if you talk to people and say that a future internet, or call it Web3, will be built on top of blockchains, and that's your thesis, I don't think it's a controversial thing anymore. Like pretty much everyone you talk to would agree that yes, the future web will emerge on top of blockchains. The question then becomes which blockchain, or what type of architecture would it be that would support a future web, right? So I think this is roughly where we are in the evolution of not just the crypto industry, but tech in general. And then I think different people have different views about how Web3 would be built. We have the Ethereum camp, we have the I'm Ethereum but better camp, and then there is the camp of a lot of kind of like new blockchains that are trying to really innovate at the layer one. Blockstack has always had a different approach, where we believe that you shouldn't put a lot of complexity into the blockchain layer itself, right? So think of something that is the inverse of Ethereum, right? Ethereum puts a lot of complexity and computations at the blockchain layer. We're the inverse of that. Very light, very thin blockchain, mostly pointers to other things. And interestingly, with the consensus algorithm I'm going to talk about today, that consensus algorithm actually makes a pretty big bet that Web3 might actually evolve on top of Bitcoin or be anchored in Bitcoin's security. And we're going to go more into why we think that and why it might be a good technical design decision as well. But in general, if you think about Blockstack, think of this as that the blockchain stuff is mostly the foundational layer that gets a lot of attention from projects. Like, everyone's talking about what's your transaction per second, what's your consensus algorithm. It's a tiny subset of the full developer stack that people actually need to build meaningful things, right? So we focus a lot on the storage system, authentication protocols, long-term storage of data is a really big question. That who's going to pay for storage? Like, how would these apps scale to hundreds of millions of users? So, like, transactions per second is not a meaningful metric. We look at things that like interactions per second that a normal user can have, and then compare them to traditional cloud computing and traditional systems, which is the background that we have. So our team feels very comfortable in terms of designing highly scalable traditional distributed systems. I think I already went through a little bit of the starting of the project, took the route of raising venture capital to effectively do R&D work, right? So we went through Y Combinator in summer of 2014. It feels like decades ago in crypto land. If people are familiar with Filecoin, so Juan was actually in my batch, and we both read the Ethereum white paper while we were at Y Combinator. My mind was like, what is this? That's a story for some other day. I give you an overview of the team a little bit. And I think, like, I want to clarify that it started off as a lot of computer scientists, but since then we have actually focused a lot more on product people, engineers who can actually take the core R&D and then commercialize it. Right? Like, there's a role that R&D plays, but if you just stay in the R&D phase and never actually commercialize these solutions and deploy them and get them in the hands of developers, then that's not that meaningful. We are driven by taking this technology to the masses and actually making a dent in how the internet is designed and has been. So what's the Blockstack approach, right? Like, we focus on the infrastructure. Right? Think of this as the traditional web infrastructure, or recently this is the cloud computing infrastructure. Most of the things is run in the cloud somewhere. And we look at replacements for each of those layers. So if you're a developer and you're thinking that, okay, I don't want to use Facebook login, you need an alternative to that. You need a decentralized, secure authentication system. Or if you're thinking that, hey, I don't want to put my data on Firebase because it's under Google, I want to put my data securely in the hands of the users, like, how do you do that? So there are different layers of the stack, and we mostly focus on those problems. And what the developers are doing is that they take the software stack, and then they're building applications that would currently at least look like alternatives to traditional web applications. As I said, that messaging apps, secure messaging apps, blogging platforms, to simple things like, I just want to do my taxes privately on my device, and I don't want to put all that data on some server anywhere. But things start becoming very interesting where when you introduce smart contract languages. Right? I think smart contracts are something very powerful, but this notion that everything needs to be a smart contract is something that we don't entirely agree with. I think you can build very interesting things that may not have that much of smart contract functionality, but then they can interplay. So we view DeFi and Web3 as somewhat like distinct, but with a very interesting overlapping area in the middle, where there can be very, very interesting interplay between these things. So these are different components of the stack. I'm not going to go into. Actually, there's a kind of like a. Sometimes I get asked by people that how is Blockstack different? Like, can you simplify it? Because there are like so many layers, so many differences. If you were to pick just two things and try to compare our approach, I would say one would be scalability, but this is not scalability in the sense of like, my blockchain can do more transactions per second than your blockchain. This is a deeper definition of scalability, meaning that can your full application stack scale out to hundreds of millions of user interactions which is what happens if you're looking at an application like Twitter or Facebook that has something like, I think, 3 billion likes on a fairly short period of time. Like, how would decentralized applications scale to that kind of scalability, right? So this is where we shine in terms of how we have really designed our system. The core difference is that you can almost model blockchains as like a mainframe that can only do like one thing at a time. It's really processing one transaction at a time. And what we're saying is that you push most of the complexity to the users, and the users can do whatever they want in parallel. Like if I'm running a program, my program should not impact what you guys are doing. But in the current blockchain design, if I'm running something that is implemented as a smart contract, let's say on the Ethereum layer, your program is now waiting behind me because the network, the mainframe, first needs to process my transaction. So it's an extremely different design from what most of the projects are like in this space, right? Like they're all trying to build a world computer. They're all trying to build a kind of like this logical mainframe. And the second thing where I think is worth discussing, especially for this meetup, is the security of the smart contract language, right? Like, we think that not everything should be a smart contract, but things that are actually should use something that is very precise, very predictable, and very secure. We view smart contracts as something like, code that is written for airlines. Like, it should be bug-free. Like, you don't want to put people's lives at risk using that code. Same with smart contracts. Like, people's money is at risk, their digital assets are at risk. So the language should be designed for predictability, security, and not for other things like speed or ease of programming and things like that. Not that these languages need to be hard to program, but that's not the number one thing that you're trying to optimize for. So these are the areas where we explicitly design for, and I think that shine in terms of our architectural differences. So I think I went over some of this already. That the mental picture in your mind should be a light blockchain layer with pointers coming out of it to other things, and a lot of focus on the rest of the stack. And how does the rest of the stack scale out? Can your storage system actually scale out to millions of users? Can your authentication system scale out to millions of users? Things like that. So any questions at this point before we dive into clarity? Go ahead.
For a project like this, where did you start off? In terms of like when you started building, it's a pretty ambitious project. Where did you start?
Oh, where did we start, or where should the developer start? I'll answer both questions.
Not the developers, but when you started building out the platform,
sure.
Did you start at authentication? Did you start at storage?
We started at authentication, right? So initially, our idea was that, as you mentioned, that it's a very ambitious project, lots of moving parts in it. We were like, hey, we don't want to take on too many challenges. How about we start with the authentication layer, and we try to build on top of an already functioning blockchain. And that's why I think even our new consensus algorithm that I think has a very interesting interaction with Bitcoin goes back to the roots of the project, where we started off by building on top of other blockchains and not having a separate blockchain. It evolved over time. There were certain features we needed at the blockchain layer, which Bitcoin doesn't have, but Bitcoin shouldn't have, because it impacts Bitcoin's security. And we ended up evolving those features as a separate blockchain.
One of the criticisms, or a few criticisms I've heard, is that you guys are trying to do too much. Like if you go a slide back, that you're trying to build that entire stack, whereas that could be better in composable pieces. Maybe the way ENS is going about it, or something like that.
Yep.
What do you say to that?
I think I say, first of all, fair criticism, right? That we took the approach of like, if we just throw pieces at developers, they won't be able to realize a full application. Right? It's different if you're saying everything is a smart contract and all you have to ever deal with is a blockchain. We think that's a fundamentally flawed approach, and I can run some examples. Right? Like when I saw the Ethereum white paper, if you just do a back of envelope calculations, that if I'm building a Twitter client, and people have actually built Twitter clients where every tweet is a transaction, that client cannot get 1 million users because it will clog the entire network. And we saw that with CryptoKitties. Like it's a fundamental design decision that do you want to just throw something that's pretty much like a toy and let people play with it, or do you want to build like something real where people can build real applications, and then you start getting into solving those problems one by one. I think, but it's a fair criticism that it's a full stack. Then the question becomes, how do you open up the stack to more people? And I think that's the approach that we're taking now. Interestingly, what has happened is that last year, especially with the SEC offerings, we had to like become a little bit more private, right? And it's directly against open source project. Like we want to operate more like open source project, but because of all these SEC regulations, like I can't even tweet without lawyers looking at it, right? So forget about being open source project. And I think this year, what we would have already started noticing is that there's an increased path to these decentralization that actually includes the software stack. So the software is open source. Take our storage system, for example. Like there could be many backends where, so our storage is conceptually like a private encrypted drive that the user owns, but the user can keep that data anywhere. It could be IPFS, and there's already a driver. And I think this year, you're definitely going to see kind of like, not like break up the stack, but open it up more and integrate with more technologies that already exist. But definitely a fair criticism.
Yeah, so I'm very interested because it seems like Blockstack takes a very different approach to a base layer currency in the system. So as I understand it, you guys are working with Bitcoin as sort of like the currency of choice in the Blockstack node system, as opposed to the Ethereum model in which you have the base level currency in the virtual machine as well. So my question is that as someone who's kind of worked on DeFi apps in the past, I really like that ability to know that I don't need to worry ever about settlement. So when a contract executes, those funds move, and then that's basically it. So I'm kind of curious, like, how does Blockstack provide those assurances to developers and users that when you have those Bitcoin show up in your Blockstack account, that those are actually there?
Yeah, absolutely. So first of all, a little bit of a clarification that what it's a separate blockchain, Stacks 2.0, and it does have a native cryptocurrency. It's called Stacks. They've actually created internationally, not in the US yet, but internationally. And the Bitcoin component is very, I think it's probably best that I run through some of the slides for describing the consensus algorithm. And then we can come back to this. There's actually part of the ability of Clarity is being able to very precisely predict the execution of the program. So the people who have tried developing on Ethereum, there's this estimation of gas fee. So you're estimating because you actually don't know what the hell this program is going to do, right? And you don't need to estimate in Clarity and on the Stacks blockchain because you know precisely exactly what this program is going to do or what this program can and cannot do even before executing. So you know exactly how many stacks you need for executing this smart contract, and the user can just send that transaction and get that executed. But there is a separate crypto asset, and there's an interplay between Bitcoin and Stacks that we will get into later. Yep.
Real quick, so like, I have a good like mental model of like how to build the Web3 stack, like or Web3 application using Blockstack. Could you discuss like what would a potential DeFi application built on Blockstack look like?
Yeah, I think it's a great question. How about we introduce Clarity a bit, and I'll try to answer that from an application perspective. So this is like a simplified version of the stack. If you don't want to look at many parts, there's storage, there's auth, and there's the core blockchain that has Clarity, the smart contract language. At a very high level, what is Clarity? It's a non-Turing complete language, and we did that on purpose, and I'm going to get into why. Right? First of all, I think people confuse Turing completeness with a language being expressive enough that you can write any program that you want. Right? Those are separate things. Turing completeness is certain characteristics. Like for simplification, think of that as things like for loops. Right? Like you have for loops, which actually means from a mathematical perspective, you cannot have certain proofs about the language and the programs that have been written. So it's more of a limitation on being able to reason about those programs if you have Turing completeness. If you get rid of it, your programs actually can become more predictable and you can reason about them better, right? That does not mean that you cannot express things anymore, right? Sure, for loops might be easier to write, but you can still express the kind of programs that you want to express in non-Turing complete languages as well. And in fact, we're not the only ones who are heading towards non-Turing complete language. A bunch of other sophisticated recent projects are pretty much going for non-Turing completeness. And I think it's a really good design issue. But that's not it. One thing that we have kind of like so the language, the main person who started working on it, his name is Aaron. Did his PhD at Princeton as well. He spent some time with the Microsoft Research Compiler Group. And then, you know, we have Jude and we have Ludo sitting at the back who have done a bunch of work. So you should direct a lot of questions to these guys. So one interesting aspect is that the language is actually not compiled. There's no compiler. And for a minute, people go like, what? Like, why? And the answer is that, again, going back to the security level of this, like, you're designing a language for a specific purpose, right? This is not like, hey, JavaScript as a language, let's just change it and run it on blockchain. You know, like, that is not the problem we're trying to solve. The problem we're trying to solve is security and predictability. Compilers can actually introduce bugs in your programs. And when they do, they're pretty nasty. And then people would go like, well, how many times do compilers really introduce bugs? Look at the history of programming languages, right? Like compilers that have been in use for 10 plus years, there are still bugs that get introduced in your programs when it goes through the compiler. So think of this as, if you compile the smart contract, what's running is actually the compiled code. What's running is not the code that you even wrote, right? In this design, you're actually publishing the code itself, right? And then the program basically gets evaluated at runtime. And it changes the way kind of like you can reason about the program or the security of it, and we can get into more details in the Jude's talk as well. But I want to highlight some of the differences. And another thing that we have noticed is related to the compiler design. A lot of people are kind of like, just like, you know, sharding is becoming a thing, that you're not asking the question that is sharding a good idea, but people are kind of like saying, I have more shards than you, and they're trying to compete with these things. Over here, similarly, like WebAssembly or WASM, people are like, yes, we have WASM support, but why should be the question, and that we need to answer, because WASM was not designed as a smart contract platform. It was designed to make JavaScript run faster. Again, that is not the problem you're trying to solve in blockchains. So we absolutely don't have WASM support. We actually don't have compiler support at all. There's some very interesting features like there are post conditions in Clarity where it's basically like, if these conditions are not true, just abort everything that the contract did. And so you could say, if my funds move, abort this contract. And again, it's around security and being able to predict what the language is going to do. I think by far the biggest difference, not all programs are going to be Clarity, and that's where I'm going to come back to your question. Like, I think we have this notion in the crypto industry that you want to build on the blockchain, go write a smart contract. Right? Smart contracts should be a subset of the kind of things you can do with a blockchain. Right? Like, think of this as like, there are many things, like almost like APIs for blockchains, right? Where our authentication system works with the blockchain through our API, but it's not a smart contract at all. Right? Similarly, our storage system, the pointers are stored up at the blockchain layer, but it's not a smart contract. But some things where the logic, so you should think about where should the logic run. If I want to share pictures with Patrick, most of the logic is running on my device, my cell phone or my desktop, and I'm discovering Patrick's public key through the blockchain, again, not through a smart contract, through just doing a lookup to an API. And he has logic running on his computer. If we are entering into some sort of an automated transaction, logic that should not run on my computer or Patrick's computer, but actually at a neutral, trustless place, that's where smart contracts come in, right? So it's not a hammer and everything looks like a nail. It's a very precise thing that should only kick in when you are talking about ownership of digital assets. So let's say that you're writing some sort of application. Let's say it's a game. Most of the gaming logic is actually client-side. But when you're talking about transferring an asset in the game from one address to another, that could be automated at a smart contract. Any other questions? All right. So I think because Jude is covering it, I'm not going to go into the details of Clarity. He's going to walk you through a really, really interesting presentation. I'm going to switch gears a little bit over here, and we're going to start talking about consensus algorithms. Right. So basically, think of this as I mentioned, the kind of architecture that we have and the kind of bet that we're making is that it's entirely possible that Web3 emerges on top of Bitcoin. Right? Bitcoin is still the 800-pound gorilla in the game. From a systems perspective, a system that has been running for 10 plus years in production, and it is the hardest network to attack, and kind of like has all of the right properties in our way. I'm actually about to publish a blog post on Nakamoto, Balaji's new publication, that gets into these architectural differences. Right? So Bitcoin actually makes this architectural decision that we are going to have a relatively simple base layer. Right? That was the fight that big blockers were having with the Bitcoin core, that they wanted to basically increase the block size, put more transactions at the base layer. The Bitcoin core people were like, no, this is already more than what you can do at the base layer. And imagine Lightning, which is like a layer 2 protocol that settles on Bitcoin. They're not trying to say build all the Lightning complexity at the base layer. So I think they're very much in line with our school of thinking. And what we're saying is that Bitcoin cannot have a full smart contract language. It has a limited scripting language, and for really good reasons, like because you're optimizing for security there. And Bitcoin is not going to have a limited kind of like transaction rate. You cannot put all of the data in the Bitcoin blockchain, and we're completely fine with that. We're talking about anchoring the security of a new blockchain into Bitcoin. Right? So the idea is that you go from electricity to a proof of work-based cryptocurrency only once. And if I want to start a new blockchain, I don't go to kind of like tweak the proof of work algorithm and ask people to run ASICs or miners and burn electricity and create another proof of work blockchain, which a lot of the projects do. Even Ethereum does that. Still is running a proof of work. You're saying is we use the proof of work token that has already been generated by burning electricity to participate in the consensus algorithm of a new blockchain that is anchored in Bitcoin's security. So it feels a little bit twisted, right? Like, okay, so is this a new blockchain? How is the relationship with Bitcoin? And I think the mental picture, if I would convert some of this into diagrams, would be there's a big Bitcoin secure base layer and a bunch of innovation happening around Bitcoin, where there's a blockchain like Stacks that supports like full smart contract languages, and the miners are actually participating in the consensus algorithm on the Bitcoin chain, because the miners need to view both chains. They need to view the Bitcoin chain because they're participating in leader election. Leader election is this process of a bunch of people are saying, I want to be the leader for the next block, and there's a verifiable random function that basically picks the next leader who writes the block for the Stacks chain. Most of the users actually don't need to interact with Bitcoin at all, right? But there's an interesting catch there, where what happens is that so the initial version of this looked like you're saying don't burn electricity, use the proof of work token, which is Bitcoin. You can burn that instead. And then the next version was like, wait a minute, why are we burning this? Right? Burning is usually a cost to mining. Mining always has a cost. Like that's the purpose of mining. You're creating a threshold of cost that everyone has to pay to be able to mine. And we were like, why can't we distribute the Bitcoin to the holders of the Stacks cryptocurrency instead of destroying the Bitcoin? Right? This is where proof of transfer comes up. And what happens is actually a very interesting dynamic between two assets, where one becomes a reserve cryptocurrency, or almost like digital gold, and the other, Stacks, is a new cryptocurrency anchored in digital gold. And if you compare that to staking, staking basically says that instead of kind of like participating through hardware and burning electricity, you have an economic stake in a cryptocurrency, let's say Tezos or ETH 2.0 when it goes live. And you're saying that I am participating in consensus, and if I'm being malicious, I can get slashed, right? And if you don't get slashed, you are earning new tokens, but they're local cryptocurrency, meaning Tezos or ETH 2.0 or whatever it is. In this case, people who own stacks can participate in consensus. They're running full nodes, they're sending some useful information on the network that is useful to miners, but you're not putting up your funds for stashing. Right? So it's a very different dynamic. And interestingly, what you're earning is actually Bitcoin, because there's two crypto assets and there's an interplay between them. So based on your holdings of stacks, you can actually earn monthly rewards in Bitcoin, whereas miners, instead of using ASICs, they can participate in consensus using Bitcoin. So it's like trying to live in synergy with something that is very secure and is likely going to stay forever, instead of trying to build our own island and then telling everyone that, hey, no, you should come and migrate over and live on our island, which I think a lot of the crypto projects are doing similar things. They're trying to start smaller blockchains and being on their separate island. And so that's kind of like the main idea around transfer, QX. And you can, like, this thing summarizes it a little bit. This is in our initial draft paper as well. So the stage we are at is basically that we have released a draft white paper. Before releasing it, we have the stacks improvement proposal process. And we currently, this proposal is not accepted. So it's going through the reviews, like you're getting security audits, we're getting consensus audits, and other types of kind of like even economic and game theory audits on this, which is super interesting. And if this is accepted, this is the algorithm that the Stacks 2.0 blockchain will go live with. And we expect that to happen over Q2, so roughly like May or June. So.
What's the governance around that?
Great question. So basically, the Stacks improvement proposal 000, we didn't start at 1. True nerds started at 0. 000 SIP describes the governance, and it's in the process of being updated as well. Because I think one thing that you'll notice this year is this increased focus on not Blockstack PBC is not the only company in this ecosystem, and increasingly getting other entities taking more ownership, letting the community take more ownership. And specifically, there is currently a proposal for an independent stacks foundation. And then again, I think foundations get a bad name in the crypto industry because a lot of people were setting up foundations to actually do fundraising, right? So this is not one of those foundations. There's no fundraising component with it. It's purely a foundation focused on governance. And what we're doing is we're actually involving all of the community, all of the developers of these 400 applications and so on to give us input. Like they can even help design the charter of the foundation. And then I think there is the governance of the stacks improvement proposal, which is more like a management of GitHub, right? Like people are sending proposals, you want to figure out that there's a bunch of seats, and Blockstack PPC likely wouldn't have majority seats on that process. But then the real governance is miners, right? Like any SIP to be accepted, you need more than 80% support from the miners for that to go live.
Thank you.
Yep.
I have a question. So why is this not, for example, like a side chain, like what RSK is doing in Sector Learner? And then number 2, like I assume perhaps with the proof of transfer, the idea is to reward the people that are building on Blockstack as well, right? So a little bit like how Zcash is trying to reward the people that are building.
Yep.
Is that correct?
So there are 2 questions. Actually, I would make it 3.
Oh.
One is why is this not a sidechain? Two is why isn't it like a project like Rootstock? It's called RSK now. And the third is what's the rewards for developers, right? Let me start with the easiest one, rewards for developers. So I think rewards for developers is something that we thought about a lot. And in our token economics paper, just like there's a distribution for the miners, there's a distribution for developers, right? And that's our app mining program. The we've been running in the pilot phase for over a year, and the program is currently going through improvements. Like we've learned a lot. We have a lot of data on what works, what doesn't work. One of the biggest learnings is that any metric that is automated, you throw that at developers, and there is money involved, developers would start focus, at least a subset of them, would start focusing more on what that metric is and how to optimize for that instead of focusing more on the application. And so interestingly, there are funds that are reserved for that. You can even imagine that as a dev fund, and developers can try and build on Blockstack for that. So that's a separate category. The rewards I mentioned, the Bitcoin, earning Bitcoin are for stacks holders. Like if you're an investor or a user who own a certain amount of stacks tokens, you want to participate in consensus, much like staking, but you're not putting up the rewards, you're putting up your holdings for Slash. Now going back to the reason I separated out RSK from sidechains is that they actually merged mining with Bitcoin. I believe the latest numbers are something like they have 40% of Bitcoin merged mining. We have a bunch of experience with merged mining. Like back in the day, we actually tried building on top of this thing called Namecoin. I don't know how many people would know this. It was the first fork of Bitcoin. It ages you if you've actually tried hacking on Namecoin. And Satoshi was involved with it. Aaron Schwartz was involved with it. And this is 2013. And Namecoin, like we are looking at, me and Ryan, we're looking at like, should we build on Bitcoin? Should we build on Namecoin? And Namecoin was literally, a bug was discovered. Kraken was still around. Kraken discovered the bug. And the bug was that anyone can steal anyone's cryptocurrency. That's a pretty serious thing. And then we tried using Namecoin, and I discovered, like, I hate to give this example because Namecoin, some of them are still there, and then they point out that no, this is not what happened. Like, I don't want to start any Twitter flame wars, but this ended up in my PhD thesis actually. There's a graph that they really made, and the graph is about mining hash power on Namecoin, which I think we discovered, but they said that everyone knew about it. And well, either way, it's a pretty bad thing if a single miner has 60 to 70% of your hash power. And the fundamental thing over there is there's a disconnect between basically, imagine that if you're merge mining, you really should try to get 100% of the miners to merge mine. If you don't, if the number is low, even at like 60% or so, a single miner, and there are miners who have 30 to 40% of Bitcoin, absolutely have full control of the merge mine chain, right? So then it becomes a political question of convincing the miners who are mining Bitcoin that, hey, please mine my chain as well. And I think this is a very odd situation to be in, and we don't think it's very, very sustainable. And in terms of sidechains, I think sidechains is definitely interesting. They're been around for a while. I still haven't seen like really good implementations. These two-way pegs also become tricky. Plus, also let's not forget that I think we support Bitcoin. We're innovating in the Bitcoin ecosystem, but this idea of they can never be another crypto asset is just strange and limited, right? Like sidechains are pretty much like lock up your Bitcoin and then push them back. Whereas if you're a new project and you have new innovative ways of using a new crypto asset, you shouldn't limit yourself by saying that no, we're not going to issue a new crypto asset, and just stick with what's already out there. So it was a long answer, but hopefully I was getting all the points. Any other questions? So yeah, this is proof of transfer. As I said, that there's a difference between a stacks miner and a stacks holder. Both can participate in consensus. The miner, basically, think of that as like they view both the Bitcoin chain and the stack chain. Everyone else, users, developers, they don't need to care about Bitcoin. They only look at the stack chain. And miners are, they view their cost of mining in Bitcoin, and they are basically spending Bitcoin, and they would mine if it's profitable for them to get the newly minted stacks tokens. So they collect all the transaction fees in stacks. They collect Clarity smart contract execution fees in stacks. They collect all the newly minted Coinbase STX. You can't use the name Coinbase anymore. People just think of the exchange Coinbase. The Coinbase is the kind of like the newly minted And then as a stack holder, you are also participating in consensus, but you're not doing that much work as miners. You're not processing blocks. That's different from staking. In staking, you are kind of like doing that type of functionality as well. Over here, you're effectively kind of like locking up your stacks for a small period of time. Let's call it a month, and you're sending certain interesting information. You're running a full node, and you're sending certain interesting information on it, kind of like which fork you're on, and that information is valuable to honest miners, and you earn Bitcoin. So that's kind of like a very high level description, and then you can dig more into the paper, or just come and talk to us because it's still a draft. So if you have questions, that helps us improve the draft as well. I think I'm pretty much going to stop here and take more questions because Jude's presentation is super interesting, and I'm going to make sure he gets some time. Cool. If you guys want to. If you guys want to learn more, I think Telegram is kind of like where you can just drop in, and then people who are actually more regular and developers, they slowly migrate to a Discord. But that's a pro level thing to do. Start with Telegram, and you'll stay updated on what's going on with the project. Let's take a couple more questions, and then I think Jude will come here.
Yep. Can you describe the database a little bit and exactly how that works and how you make queries and data and stuff?
Yeah. So great question. It's not a database. I think you should. I'm going to explain both the technical way of modeling it and the user side of it. So for a user, your model is that it's my private encrypted drive. It's like your home drive, and I could have done just an entire presentation on it. Like imagine that users never had a home drive on the internet, right? Like your private home drive. So instead of like you're visiting 100 websites, every website is writing data about you in their own database. Those websites will be writing data in your home drive, your private drive that you control, and you have the keys to it, and you store it. That's how users view it. In some ways, it's like desktop computers, right? Like you add a drive, and you're supposed to back it up. So our software helps you back it up at multiple places. It gives you performance of cloud computing and so on. From a technical perspective, I think it's probably best to model this as a wide area file system, right? So it's kind of like a file system, but it's wide area, meaning like you can plug in underlying areas where you're actually storing data. So we write drivers for these things. We write drivers for cloud providers. We write drivers for simple Linux. It could be anywhere where you can store data. You technically can use the Gaia storage system for storing data. It's just a driver, just like any hard drive would work if you have a driver for it. Any cloud provider, any IPFS-like system can work if you have a driver for it. And it works as a wide area file system that has access control built in, right? So if you want to share something with me, that's where the blockchain comes in, because all the access credentials are linked through the blockchain. So you'll basically look up my public key, and you'll be like, hey, here's a folder shared between me and I'll drop some files in it, and that's how sharing works. So it's a whole different system, whole different talk. And I think one of the things we will start doing is going back to like Blockstack is an integrated stack, and it can actually open up a little bit more. Even like websites and information, like in my mind, it makes complete sense that you go to the main Blockstack page, and it's just like software for a user-owned internet. And then if you want to learn about Clarity, you go to the Clarity website. If you want to learn about storage, you go to the storage website, and all the different components can be laid out there. And maybe we'll do that.
How does Blockstack interact in the future with Handshake? Something like that. Like how does .id and Handshake? Like I'm trying to kind of wrap my head around how that would work in the future.
So here's the thing that I didn't get into. Like there's a built-in DNS system. Think of that as almost like a smart contract where people are buying domain names as digital property. Handshake started off as just an alternate DNS route, but eventually they ended up having a blockchain as well. And I think it's effectively, I'll give you the answer of if they really want to build on Blockstack, they should use Clarity and implement their smart contract that way. But I think that there's a very interesting thing happening where a lot of these crypto projects are realizing that domain names are an interesting idea, and we should have support for domain names there. And one thing that I'm playing around with, and I might start proposing it to a couple of exchanges, is that all these crypto projects have actually standardized tickers as well, right? So it's very clear when you say ETH, or very clear, like if you say STX or BTC or something like that, you could actually turn that into TLDs and plug in whatever kind of like naming system that they have internally, but you need support for resolution. And I think this might be a way to like in crypto, there's a lot of like anger and infighting. This might be a way to get everyone on board that you can have your own TLD, you can have your own TLD, and you do resolution that way.
So it'd be kind of almost like moving up a layer. So it'd be instead of
Yes.
.com, it's xxx.com, and then you're building on top of that.
Or at some point, if it can be integrated with traditional DNS, if you will. But that would be down the road. The first step would be like conflict resolution and in between projects when it comes to domain names. And Jude, I think you can come up. Well, thank you so much, and thanks for coming here.
Cool. While Jude's getting set up, just want to say thanks, Mindy, for that presentation. That was really helpful. You all got the Twitter handles and all that. That's good. Anyways, cool. So Jude, yeah, keep talking. No, I need to talk. I'm gonna hand it off to Jude now. He's got a really interesting presentation. I missed the last one. I got the first few slides, and I had to duck into a call. So I'm looking forward to actually catching this one this time. Everyone had really good reviews last time.
Yeah, I just need to set your section on the Wi-Fi so I can turn on the presentation here. In this episode of Jude tries to configure his laptop. Hooray! Hi everyone. Everyone in the back can hear? All right, cool. Hi, my name is Jude. Been working on Blockstack for just over 5 years now. And today I'll be talking about Clarity smart contracts, the how and the why, and the good, the bad, and the ugly. But first, very high level about how Blockstack works under the hood. We need to touch on this a bit, but the theme in which, but it helps to clarify the context in which we design Clarity. Right now, the web kind of looks like this. There's you and your friend and the app that you happen to use to interact with them. Let's say it's Facebook. If I want to share my post with my friend or share my pictures, share my wall, I have to sign into Facebook and I have to put the data into Facebook. And Facebook, takes that data and puts it onto their servers. And if my friend wants to see it, they have to also have an account. They have to sign in and then get that data back from Facebook. And this positioning for Facebook is kind of uncomfortable if you think about it, because Facebook's kind of like the judge, jury, the executioner for all the things, all of my digital life now on Facebook. They decide who gets to sign in, who gets to see what. They decide what the security model of my data is. They can leak it, they can do bad things for it, like give it to Cambridge Analytica. So they misuse my data. I can't really do much with my data beyond what Facebook lets me do. They get to reap all the benefits, make all the money from it. And if I'm a developer, for example, and I have some better ideas about how Facebook's client should behave, like let's say, for example, I only want to see cat pictures, I can't make the Facebook client do that as much as I would like to. Facebook can't please everyone either. They can't know the needs of a third of humanity. But they kind of put themselves in a position where they are kind of forced to build this one-size-fits-all solution to everyone's detriment. So what Blockstack's really about is switching the relationship between applications and your data like this. In Blockstack, your data is the center of the universe. You put your data into your data vault. You choose how the data gets stored, where it gets stored, and who gets to see it. And we enforce ownership and privacy through end-to-end encryption. So when I store my data, it should go to my data vault, and my friends can see it only if I've encrypted the data such that they're able to decrypt it. So now, the likes of Facebook are just clients of my data. They're downstream consumers like other users, and they serve at my pleasure. If Facebook's going to misuse my data or not do things with my data that I approve of, I can simply not encrypt my data with their key, and then they can't see it. They just see ciphertext and gobbledygook. This also means that I, as a user, if I'm a developer, have a free choice in the client I use to interact with my data, because there's no Facebook middleman anymore forcing me to use their one client. I can build my cat pictures only Facebook client if I felt like it, and anything you can imagine for that matter. So separating data from the application liberates users and makes their lives better.
And it also gives applications a reason to want to innovate and improve so they can earn your business instead of locking you in. So that's a key theme of Blockstack is that we focus on building these applications where users own their data, and we call this the can't be evil paradigm of applications. It's not don't be evil. Like you can't, like sure, maybe the app developers can say, yeah, trust us, we're not gonna share your data or do nefarious things until we do because it makes us money. It's we build the system so that they can't do that sorts of thing in the first place. But that said, we are very much of the opinion that most of applications can still be realized without invoking a blockchain or using smart contracts. And in fact, our software stack reflects this philosophy. Applications are a few degrees removed from the stack's blockchain. Beneath the application, we have our Blockstack JS library, which is kind of the glue that binds the lower layers together. I know there was a question earlier about unbundling these things, and here's some good news. We have Radix, Gaia, and Collections, which are already kind of standalone systems right now. You can have a Gaia system without the Stack's blockchain or without Blockstack JS. It's just a normal HTTP server with a certain authentication protocol. And same for Radix, which is an indexer that lets you build materialized views over many users' Gaia hubs, as well as a collections library, which helps make it so that you can safely share data between applications without having those applications trample all over each other or do nefarious things with the shared state. And finally, beneath it all, deep beneath it all, we have the Stacks blockchain, the Stacks 2.0 blockchain specifically, which solves a handful of problems that cannot be solved using just Gaia or just this user-owned data paradigm of building apps. I believe Munib had this slide as well. In Blockstack, most of the business logic compared to other approaches is meant to run off-chain, with the blockchain having only minimal involvement. And our focus on smart contracts for when they need to exist is built around making them decidable, so not Turing complete, so you can enforce certain safety properties about them, which I'll be focusing on in this talk. And importantly, in the spirit of can't be evil, the smart contract source code, as in what the developer intended to happen in the smart contract, is interpreted and it lives directly on chain, so everybody and anybody can access it. That said, any Ethereum developers here? So you all used Etherscan? You ever have try to use it? You ever try to look up the source code to a smart contract only to not find it? Couple nods. Yeah, we don't have that problem because it's always there. So that's it. Let's delve into that a bit more. So smart contracts, we believe, are primarily meant for the case where you have some global shared mutable state that users have to agree on, but where you can't necessarily trust one user or even a minority of users to deal with correctly. Relevant and pertinent to DeFi because this includes basically every single DeFi application. It's not like you can just trust me with your balance. You shouldn't do that. I'm not a bank. And I wouldn't trust myself with that either. But fortunately, the state for these things can live in a distributed computing medium that ensures that any mutations to that state, so like changes in balance, only happen with the consent of the majority of users. It's crucial that this logic runs outside of any single user's devices, but remains structured and held in such a way that anybody can make changes with them as long as they're amenable and agreeable and follow a well-defined protocol. So that said, some key use cases I see in Blockstack, at least, for our smart contracts are building things like user communities or admin tools or subreddits, like in Reddit. Like the state of all subreddits shouldn't be just in my server or just the developer server. Anyone ought to be able to make a subreddit. So subreddits and the people who administrate them is shared mutable state in the context of a forum-like software. Same idea goes for things like infrastructure and discovery. Like how do I find out like where your store is on Etsy or on eBay? The store registry is shared mutable state. The items in that store are mutable state that only you can write, but the ability for you to register that store and update that store is something that that no one should constrain you from doing. Similar logic applies to things like license keys and subscriptions. If I were to go build Netflix on this system and I buy a subscription to it, the state of who is paying for the video feeds, that's shared mutable state. And of course, I'm kind of going through this kind of fast because I know that Munib kind of talked about most of this, but I think relevant to DeFi, obviously the state of everyone's balance and everyone's tokens. That's shared mutable state that shouldn't be trusted with just a single person. But that said, and I'm in the process of curating this bingo board here, there's a lot of problems and deficiencies with existing smart contract platforms, which ultimately compelled us to consider building our own smart contract system. So without further ado, my smart contract footgun bingo. The Turing completeness is a free square for a whole lot of reasons I'll be getting in momentarily. I see a lot of advertising spent on, like, oh, you can use any language you want. You can just compile it into your smart contract. And we support every single language under the sun because we have a backend for GCC and LLVM, so you can write C if you want to and translate that into a smart contract. Of course we support JavaScript because, you know, JavaScript is a great language for dealing with other people's money. Same with WASM. It's like JavaScript, but even less scrutable. And you know what? It's all good, guys, because if you just formally verify all of your code, it'll be bug-free. Who's verified their code formally? Raise your hand. Who has ever done formal verification before? How long was the line? How many lines of code were verified?
Like 10.
Yeah, 10. Yeah, no one does this. So what that really means, of course, is that every piece of code we all write. Okay, other question. Who writes bug-free code? Okay, I'm going to call your employer and have them fire you because you're a liar. Yeah, no one writes bug-free code. So we shouldn't be writing smart contract platforms to assume developers are superhuman bug-free code writers. They aren't. We're all human. And I know composability is the big buzzword right now, but what I want to draw your attention to is unbound composability. It's 10 p.m. Do you know what your transaction is? Do you know what your transaction is doing? If anything can call into anything else, you're suddenly in this Turing tar pit of undecidable states that your transaction may or may not be in, and lo and behold, your money's all gone. Oops. So what I'm going to try to convince you of in this talk is that all of these things and more are anti-features. They're problems in smart contract platforms. These features cause a lot of harm in practice. These things here should not be possible. And I really do mean impossible. I really mean they should not be possible. Like, the DAO happened. Like, that guy is A, still at large, and B, the DAO really changed the face of Ethereum. It certainly drove a lot of controversy and a lot of noise into the space. But the fundamental question here is, why the hell does reentrancy exist? Why the hell was that even possible? Another point, 0x going down because of handwritten bespoke EVM assembler. Like, why? That's a big problem. Like, a bunch of people could have lost money there. Like the multi-sig hack for parity, $200 million. Poof, gone. Hundreds of transactions aborting per day because they run out of gas. Well, unfortunately, like Turing completeness means that you're not able to tell how long your transaction is going to run for, so you kind of have to suffer this indignity, even though it could have been avoided if you thought about your language a little bit more. And if you want to go start building smart contracts and then prove them correct, well, chances are you're going to have to pay somebody a lot of money to go and audit it first. Like, we shouldn't be trusting blockchains to the capacity that we are now. The hard lessons we've learned watching the state of smart contract evolution for the past umpteen years is that blockchains don't forgive and they don't forget. The code is still the judge, jury, and executioner. And unfortunately, bugs in smart contracts are functionally indistinguishable from malice. You don't know whether or not it was intentional that the DAO got hacked. It's just this thing happened and the community decided it was a bad thing. Like, that's not knowable from just the code itself. And the problem with these smart contract bugs is that they cause large-scale, potentially irreversible harm. Like, that money's gone. It's spent. You're not getting it back, not without reorging the whole chain. So this by itself means that blockchains can potentially be a far worse platform than what you get today, than with centralized services. Because at least with centralized services, you could sue people, and you could put people in jail for hacking your smart contracts. Like, these people are still walking and at large, and that's probably going to be the way for a long, long time. The problems here fundamentally arise from unaccountable, unsafe code that decides the state of your application. And blockchains and smart contracts by themselves do not fix this. The code can still be evil. I, as a developer, can intentionally write a buggy smart contract, and I can go on a media blitz and try to convince you to send money to that smart contract and walk away with the money. I can exit scam still. So for smart contracts trying to reduce the need for trust, they don't do a really good job today. And even the best developers with the best of intentions can't protect you from unknown unknowns, the problems they don't know about. I'm not clairvoyant. I can't see into the future and see hacks that I don't know about. And while composability is a great idea, if you're not careful about how you do it, it leads to very hard to reason about states that your transaction can get into, leading to uncheckable errors. Like, how do you even know whether or not a transaction is going to cause all your money to disappear or cause somebody else's money to disappear. So the question I pose to the audience is, how do we avoid repeating the mistakes of the past? So if I had a wish list for what went into the runtime environment for a smart contract platform, it would be these three things. It should be really, really, really hard to write dangerous, inscrutable, or quote-unquote clever code. And to remedy this, I propose that the source code should always, always be available. And the contract always should do what the source code says it does. So that precludes having a compiler. Just because you took your code and you compiled it down to bytecode doesn't necessarily mean that bytecode is semantically equivalent to the source code. If your compiler has a bug, then the question becomes like, which is the real code? What is it supposed to do? The contract's not doing what it says it's supposed to be doing. The second wish I would have is that it should be really easy to figure out what the code does before you run it. I should be able to know what other smart contracts are going to get called by my transaction. I should know the set of reachable smart contracts. I should be able to tell what types they are. I should be able to tell what the runtime cost of running the transaction should be before I even send it onto the network. This is, I think, a much more reasonable idea of composability than what currently exists. And finally, the big wish list I have is that users have to be able to proactively defend themselves from bugs. You shouldn't have to trust developers with your valuables, even ones who write intentionally malicious code, or even ones who, with the best of intentions, don't write malicious code but still have bugs. Like, why are we trusting our assets like solely and exclusively to the code that some other person who you can't even sue wrote? The system should allow you to protect yourself from the source code of smart contracts that could do you harm. Using this wish list and lessons learned, we designed Clarity. We came up with a set of design principles for a smart contract language. And there's as follows. There is one programming language in the Stacks v2 ecosystem. It's Clarity. There is no assembly. There is no bytecode. There is no compiler. There is no foreign function interface. There's no need to try to figure out whether or not language A and language B can talk to each other. One programming language. The second principle is that what you see on the chain is exactly what will run. The source code will be interpreted in place. And as I'll explain later, the Clarity language is designed to be very easy to interpret. It's very easy, comparatively speaking, to write a correct interpreter for Clarity. The third principle is that reentrancy and unchecked dynamic dispatch are forbidden at the language level. It must always be possible to deduce the set of reachable code from a transaction. The fourth thing that Munib touched on briefly is this notion of post-conditions on assets. So post-conditions are a set of logical statements about the final state of all of your assets in the system right when the transaction code terminates that must all be true for the state of that transaction to be materialized. If any of them are not true, the transaction aborts and you just lose the transaction fee and that's it. But you keep everything else. The fifth principle I have is static cost analysis. There is no out of gas in this system. A transaction is mined or it's not mined. It's much more like Bitcoin in that capacity. Like a miner won't pick up your Bitcoin transaction and then not materialize the effects of it. And that's something you can only get from having decidable execution. And our sixth principle is this notion of migration. So who's written a smart contract before? You ever try to upgrade your smart contract? Yeah, it's not fun. You have to go resend all the transactions to go move all the state over. And in this system, that is a zero-cost operation. It is possible to query the state of the blockchain at any point in the past, and there is 0.1 time complexity for doing this. So that said, there's three main ways through which we interact with the Clarity interpreter. There's the notion of defining a smart contract, which at the point of smart contract instantiation, the system will determine and store the runtime costs of each code path that could possibly be taken. It'll do all the type inference you'd expect of a strongly typed programming language. It runs any bare setup code, so you have a chance to instantiate the smart contract with the state before anyone else can call into it. And it makes that code discoverable. So you can just hit up your node for the source code for any smart contract you want to invoke. This is great for wallets because then they in turn can show you what code your transaction might call. The second way you interact with the Clarity interpreter is through a contract call transaction. It invokes a public function from an already materialized smart contract, and it uses internally the analysis data derived from instantiating that smart contract to determine what the maximum runtime cost could be. And finally, there's this notion of post-conditions, which are tacked into your transaction and run outside of the Clarity VM and are added by your wallet. So you don't even have to worry about writing it in yourself as a user. Your wallet just gives you a way to say, oh, hey, for this asset, make sure I sent no more of this. Or for this other asset, make sure the other guy sent it to me first. If any of these post-conditions are false, then no side effects materialize, no one's assets move. You just lose a transaction fee for the process of validating and mining your transaction. So that said, I know that maybe 40% of people, I think Patrick said, in the audience are developers. If you're not a developer, I apologize in advance because this part is going to be code. But I promise you, I learned this language in about an hour, and I have never learned a language like this before in my life. The Clarity language is based on an old family of languages called Lisp. Those of you who are programmers might suddenly be a bit averse because there's lots of parentheses involved. But the reason we chose a Lisp as our dialect is because Lisp is probably the easiest language to write a correct interpreter for. And that's good, because you want a correct interpreter, and you want that interpreter to be easily verifiable. It's also a strongly typed Lisp, so you know what each method is going to take as inputs, and you know what each method is going to give you back as an output. And our system has first-class types for assets, for fungible assets and for non-fungible assets. And that lets us do things like have post conditions and maximum mints and other sorts of statically guaranteed properties that you don't get out of materializing your token as like a data map. I mentioned earlier the static runtime cost analysis, some primitive support for algebraic data types, so like an option type and a response type, if you're familiar with Haskell or Rust. I'll get into examples of this in a moment. We do support safe dynamic dispatch through traits. I can define the interface that a contract must have, and I can concretize that trait with an actual contract later on. That lets you get all the nice things of composability and the nice features of dynamic dispatch without worrying about code calling into any other point in code anywhere else. It's type checked, and it won't run unless the types are all correct. That said, Clarity is a non-Turing complete language. It's all decidable. There is no recursion, there are no lambdas, there's no anonymous functions, no unbound loops, no dynamic dispatch. But it turns out you can get a lot done without those things. In fact, you can get a lot done we can get so much done with these things that like we have yet to find a thing that we couldn't do in our toying around with the language and building out some prototypes. So that said, let's get into just a little bit of this language here. Hello world. Pretty straightforward. So we get into Lisp, so lots of parentheses. The way you define a publicly callable function is through this define public directive. The next term in the parentheses here is the name of the function, in this case, hello. Hello takes one argument, a name, that is of type buff40, so a buffer that has at most 40 characters in it. The begin directive tells you that here's a list of statements I want to execute. In this case, I'm just printing hello, comma, your name, and I'm returning OK, true, which is an indication that the transaction, if it calls this method, will exit successfully. If I want to call hello from another smart contract, we have a way to do that through the contract call directive. Contracts every contract has a name in two parts. It has the address of the developer who instantiated it. In this case, it's this long cryptographic string here of SP5N, etc. Dot name of the contract. So this contract was called hello, and SP5N yada 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 dot hello is the fully qualified address of that contract. Similarly, I know that it's a very common practice to split up your source code into multiple files, and if that's the case here, there's a shorthand way to invoke methods by just saying .hello in this case, if you happen to be deploying code under the same address as the contract. So no need to go fill in tediously the address of anything. The system automatically knows that that's implied if you're calling methods from between files under the same address. Data types that we support, no float type. I don't believe in float type. You shouldn't be using float type for your money. That's bad. It's not precise. We just do integers, 128-bit integers, signed and unsigned, as well as buffers, like for strings, as well as lists, which are the building block for everything in most Lisps. There's a Boolean type, your typical tuple type for named records, optional and response that I mentioned earlier, as well as a first-class type for principals. And not shown here, but are implicit in the language design, are types for your assets. So we do support the notion of structured programming. We have a defined private for methods that are not meant to be called publicly, and these are just inlineable. In fact, the code will not be instantiated, the code cannot be inlined, and that is a way that we guarantee the citable execution paths here. Here's a very simple example. We have a function called, so we have a statement here, bare code, that defines a variable called the sum as a call to adder. Adder is a function that just takes two integers and adds them. So I'm saying let the sum be equal to adder evaluated on 1 and 2, and that should be 3. And the typical Lispisms, you have if prefix notation here, not infix like most other languages. If the sum is equal to 3 and adder 1, 3 is equal to 4, then everything is fine. Otherwise, math has failed us, and we're screwed. But anyway, the nice thing, I think the mic just died. Can you all hear me? All right. The nice thing about this, even if it might not be as clear as languages like, say, JavaScript at first, is that this is basically in one-to-one correspondence with the abstract syntax tree that would come out of a parser in the first place. That's a nice property because it means the code required to translate the source code into something that can be interpreted is very simple and very easy to audit and verify is correct. This is not true for languages like JavaScript or Python, which require multi-phased parsing passes to make sure that everything is kosher. We believe in making sure that the blockchain is minimal insofar as that it guarantees us better security properties. So the choice. Sure. On that said, that's better. Clarity code structure. More of the same. Map, filter, fold, the building blocks in most functional languages. Taking length, concatenation, as well as a few built-ins for doing hash functions. We do have the ability to query things, to run code as if it were happening earlier in the past in a read-only fashion through @block, and that is the migration path I mentioned earlier, as well as the usual things you'd expect, like who's running the code, txsender, equivalent to message.send and solidity. The system provides global variables as well as global data maps, which can be read but not written to by other smart contracts, as well as a native asset type. I can define fungible tokens that grow unbound or that are capped. In this case, 100 Club is capped at 100 units that may exist, as well as operations to mint those tokens, get the balance out of an address, as well as transfer them. Similar for non-fungible tokens. For example, I'm defining an NFT here called the Gym Pass that is above 20. I can mint them, get their owner, and I can send them to new people. Sorry, I'm going fast. I was just asked that we have to wrap this up in like 5 minutes or so. But that said, interesting part here, post conditions. You can think of post conditions as read as when a transaction finishes, the following will be true about who transferred which tokens and NFTs. Think of this as like a safety belt for your user's assets. So if your code crashes, your assets are safe. The wallet adds them for your transaction automatically, and it's meant to let you proactively defend yourself against buggy code. Because the post conditions make sure that even code, if you haven't audited it yet or made sure it works correctly, all that's going to happen is you lose the transaction fee. But everything else stays the same as it was as if your transaction never happened. In this example, I have a malicious smart contract where I have a token that's, let's say, valuable called stackaroos, and a token that's not valuable called fakearoos. I have a public function called steal from me that takes money from the transaction sender and deposits it into an evil wallet, whose full address I'm eliding because it's too long. And suppose I have another public function called bad trade that forces the caller to trade their stackaroos for fakearoos. I don't want to call either of these. That's bad. I don't want it to be possible for another contract to call into this either, or for there to be some sort of labyrinthine series of contract calls that lead to this happening. Post conditions save me from this, because I can tack on things like, when this code finishes running, I will have sent 0 stackaroos. If that's not true, the transaction aborts, and my stackaroos are safe. I can do it other ways too. I can say the victim never sends stackaroos, or the victim never gets a balance of fakearoos. The point is, it gives me a very simple way of reasoning about keeping my assets safe, and this is only realizable by making assets a first-class type in the language. You can tack on as many as you would like into our transaction. They're very cheap to evaluate. They take no I/O at all, no I/O beyond what's required to evaluate the transaction. And you can define them for any principal, and you can do so in an allow deny mode. For example, I can say that if I did not list an asset, but an asset moves, then the thing must abort. protecting you from bugs and problems that you don't yet know about, and allowing developers to be human and not be forced to do unreasonable amounts of formal verification before they can publish their MVP. So just wrapping up, Clarity is a next-generation smart contract language that's meant to provide defense in depth for users while still remaining expressive enough to do nice things. It's open source, GPL3. Our repo is github.com/blockstack/blockstackcore. Feel free to try out our local testnet. It's written in Rust. Instructions to run are right here: cargo build, Blockstack core testnet, and of course we have the Discord if you're a developer where we talk about all these things. Sorry I had to rush there at the end. Questions? Surely there's at least one. Yes?
So in the case of contracts calling other contracts, can you write something kind of like a DEX, like a decentralized exchange on top of Blockstack platform?
Yes, you can. We do so by using traits. So I would define a trait saying like any contract that implements this trait has a trade function that takes two principals and their amounts they want to trade for. So then the DEX can just make new smart contracts for each new tokens it support, and in doing so it concretizes that trait in order to support newer and newer types of tokens. But you still get all the safety features and the type checks you would get out of Clarity in doing so. Yes?
I guess this is more just a general question about Blockstack. I recently read that you guys had unlocked new funding because you hit a user milestone. I was just wondering, like, what kind of activities those users are doing, like, what kind of applications are they interacting with?
So that's an interesting question. Our system is designed so we can't watch what they do. That we'd be pretty evil if we could. The second thing is defined on a per app basis, so you have to ask me by which application you have. Like for example, we have Sigil, which is a blogging platform. They occasionally will share like how many monthly views they get. I think they're at maybe 5,000 or so. That said, the metric that we had, as legally defined in our milestone 2 paperwork, is that we were trying to get 1 million users to try out the platform to the point where they're willing to register usernames, and that's what got us the unlock. Other questions?
Yes. So like you mentioned not like don't be evil or can't be evil, but what's stopping people from trying to keep you from like that's a strong capability. So what's stopping the state government or authoritarian figure to try to kill that ability? Like, what are the risks and like, what are the attack measures?
I mean, they could throw me in jail, right? They could take anyone running the software and throw them in jail.
Technically, I mean, like technical standpoint, not like a figurehead, but if there is one.
So I mean, what applies to most other systems applies to us too. It's a peer-to-peer open membership network, so they would have to corrupt all the network links between the victim and anyone else who's running an honest node. So be that as it may, that's about as best you can hope to do under the circumstances.
Only from infrastructure, right?
What's that?
Only from the infrastructure standpoint, right?
Yeah.
Okay.
Yes.
The smart contract code is you can advertise it so that anyone can see it, say while running it from a wallet. But does it have to be open, or can someone actually have a private smart contract that a wallet can call it?
Oh no privacy.
No privacy.
Because we want it to be the case that you can see what's going to manage your money. Like, smart contracts manipulate other people's valuable assets. It's not fair to them to have to suddenly trust this private, unauditable blob of code that may or may not eat their money. So we force everything to be open for their safety.
So I just want to announce quickly the winner of the Blockstack book bag. The email is kamekudze5026. Can you raise your hand if you're in? If not, we have a second place, I guess, or second selected. milichcam@gmail. Okay, no. Cool, we got number 3, Joe at JSL Ventures. All right, and that's no. All right, great. Cool. Rose Mayrod at Gmail. Oh, she went to the bathroom. I'll just leave it. I'll leave it here. All right, great.
One more question, and then we're gonna wrap up.
One more question. Yeah.
Is there any easy way to think about interoperability between like an NFT built on Ethereum and an NFT on Blockstack?
You could have it done on the client, for example. Does that make sense?
You can explain it to me later.
Okay.
Or you can explain it here. I don't want to waste anyone's time.
I mean, I could have a wallet for both, right? In fact, Blockstack apps being primarily hosted in the web browser, just throw web3.js and voila, you can now interact with your Ethereum NFTs as well as Blockstack NFTs. Yes.
Yes.
It's the source code.
All right, thanks for coming, everybody. All right, I guess you can find Jude afterwards. Thanks for coming.